perform ANOVA. Okay. Now, see, the what ANOVA we have performed is, what ANOVA we have performed is the one-way ANOVA, right? One-way ANOVA. Now let me show what is one-way ANOVA and what is other ANOVA we will see, right? Okay, so now okay, so okay, so now I have some variables. So among these, I have some variable, right? So the variables are, okay, so one is designation. So one is designation having some designations. Okay, so then another is total savings, so which is a metric variable. Then age, which is again category variable, having 3 category. Then income, I have, okay, 5 categories. So I have, so here I have, okay, so 3 category variable, right? So designation, age, income, and the saving is a metric variable, right? So now let me go to one way ANOVA and we will perform, right? So now analyze, compare means one way ANOVA. Yes, madam, madam, one way ANOVA.
Sir, dependent list, sir.
We have to put a metric variable. Okay, so that is most important.
Sir.
Now, okay, so let us take the designation here. Let us take the designation here, right? Designation here, right? So now I put designation as a factor variable, right? So now, okay, so now we can see the output. The output source, source. So 0.000, which means there is a difference. So different designation category people, they save differently, right? Their saving is different. Different designation category people, they save different. Okay. So when we want to look at the who is saving more, because we say there is a difference. Okay. So we need to go for analyze, compare means
one way ANOVA.
Okay, so if you know, you can tell, madam. So I have to perform the post hoc, right?
Yes, sir.
So before performing post hoc, actually I should check the homogeneity. Let us assume that and all there. Okay, so we will perform the tangent and we will continue and we will say okay. We will say okay. So then we will get, okay, so now if you look at it, okay, so the lecturers at that time we had lecturers, senior grade lecturers, reader, all these things. Okay, so the lecturers, they save less, and senior grade lecturers, they save 7,000. So 2 groups. So these 2 people, this one, the reader, they save more. Reader, they save more. So you could find there is a difference, right? So there are 3, 4, 5 categories of people, but they are not actually 5 category with respect to savings. They can be divided into 3 category. So lecturers and senior grade lecturers one, and the professor and the selection grade another one, and the reader we can make it as one. So like this, we can have 3 distinctive categories with respect to savings. Okay, so now we say there is a difference in the designation. Now, if you look at the variables, now I have okay. So I have another variable age. I have another variable income. Like this, I have many variable. I have many variable. All are categorical variable. I want to find out whether the people they save different saving with respect to designation I have saved. Then I might be interested to find out whether the age, whether different age people, whether they save different. Okay, whether the age, otherwise let me say whether age is having influence, whether income is having influence, right? Whether they which when it is making a difference, which means we can say there is an influence, right? Because the age people they save differently, because which means the saving is depending on say age, saving depending on income. So we can say income is influencing, right? Though we say difference all these things, so the word influence all these things, so you can use, you can so depending upon the occasion. So now I have to perform, okay. So now I have a 3 category variable. I have 1 metric variable. So I want to take perform whether in each category variable, whether they are different. Then what I have to do is, okay, analyze, compare means if I go to one way ANOVA, so here I cannot put all 3 together, not possible. So at the maximum, I can put only one factor variable. So that is why only one categorical variable, otherwise called a factor variable here, right? So I can put only one factor variable. Okay. So that is called the one-way ANOVA, right? Now, suppose if you want to put 2 factor variable, then that is called a two-way ANOVA, right? When you have 3 factor variable, that is called a three-way ANOVA. So one factor variable one way ANOVA, 2 factor variable two way ANOVA, 3 factor variable three way ANOVA. So like that we will be having many ANOVA. So instead of calling 2-way ANOVA, 3-way ANOVA, 4-way ANOVA like that, we will have many ANOVA. So we can call with one common name, all with one common name. That is called the factorial ANOVA, right? Factorial ANOVA. So what do you mean by factorial ANOVA? We will have many factor variable, that is called the factorial ANOVA, right? So now see, one madam or sir have asked, sir, one category of variable you can take 2 metric variable. Yes, definitely you can take. Definitely you can take. See, for example, I got one example. No, see, for example, I have. Okay, so definitely in one way ANOVA you can do, right? So what? See, we will go to that also. We have demonstrated. I will repeat it. Okay.
Okay.
So now, see, for example, in the independent sample T test, we had motives, right? Okay, so I have motives here. So now I have one categorical variable, Okay, so
Screen is not visible, sir.
I'm opening new, no, it may not be visible.
Yes, sir.
Okay, so I have one. So if you look at this one, okay, so always this three black spot, here one black spot, here one black spot, here one black spot. How to perform with a small screen? Okay, so now I have one categorical variable gender, so and another two metric variable, right? See, see, category variable only two category, which means I can perform only independent sample T test. But you can perform ANOVA, but the problem is, okay, so what is the problem? You can perform ANOVA in fact. So earlier, a old version, it will not allow. Now these versions and all, it will allow. But you will have some problem. What is that problem is, okay, so two category only I'm putting here, right? So now let us say okay. So if we say okay, see for example, two ANOVA are performed. You can see two ANOVA, each one factor variable. Okay, one factor variable with one metric variable. See here, one factor variable. Okay, one metric variable. Okay, so the male and female, they are different in, okay, so self-support motive. They are different in self-support motive. We have seen the other day, male having higher motive than female, right? With respect to family-oriented motive, there is no difference. This fact two is a family-oriented motive. So there is no difference. So what happens? We are getting one ANOVA to find out whether the gender, they are different in self-support motive, the top one, right? So we have put two, right? What we have put, right? ANOVA, we have put, so we have put two here, right? So we have put two here. So whether the sex, whether they are different in this motive and whether they are different in this motive, right? So it will give report to significant value. It will report independent sample also. It will report two values. Okay, so see what is the difference between this independent sample T test and this one is okay. The significant value all will be same. But the F value is different from T value. If you observe, right? If you observe, right? For example, you note it down, I will tell. So 981. So this is 0.184, right? 184. Let me perform this significant value 0.002, right? What is the difference? I will tell, right? Point. So when you can perform ANOVA itself, then what is the necessities are that I will tell. Okay, so let me perform independent sample T test. So two metric variable. Okay, let me put it here. One category variable, let me put it here. So define groups 1 and 2, 1 and 2, continue. Okay. So now if you look at it, okay, so look at the significant values. So the significant values are same. Okay, so now see here significant value 0.002, 0.668. There is no, okay, so because this is greater than 0.05, so we have to look at the first one, right? This is also greater than 0, so we have to look at this one. So 0.002, 0.68. But what is the difference is, right? So now the how T and F are related, very simple. F is T square, right? So now 3 square is 9, that is what 9.681, right? So this is 0.4 square is 0.02, right? Okay, so like that is why 0.184. Okay, so T F is nothing but the square of T. This information also you can take it to your mind. F is square of T square is F, right? Okay, so now here, see here, when you perform independent sample T test, it gives many things on its own. We can find out the mean value here, right? But you can see the mean values. Family oriented motive, there is no difference. But self-support motive, right? There is a difference that you can see. Okay, that is a difference you can see. But when you perform ANOVA, what will happen? Analyze, compare means one way ANOVA. See, I want to find out the mean value, right? Whether who is having, because there is a difference in family or self-support motive. I want to know whether they are who is having more. So if I perform the Tankan, post-hoc Tankan, right? I am performing post-hoc Tankan to get the mean value. Okay, so now, see, it will say post-hoc tests are not performed for this one because there are fewer than 3 groups. Okay, so when it is 2 category, post-hoc test will not be reported. So which means you will not get the mean value, right? You will not get the mean value. So you have to perform only the independent sample T test, right? So that is why we say, okay, when it is 2 categories, you have to perform the independent sample T test, right? Very good. Okay, so these are all we have seen the other day. These are all we have seen the other day. Now, what we are going to see is, see, for example, see, when you have 2 metric variable, I can put in the top. So which means we are performing many ANOVA symbol, right? But if I have 2, okay, so if I have 2 categorical variable, I cannot perform simultaneously because it is only ANOVA, right? I have to go the only the factorial ANOVA. In a factorial ANOVA, you can put any number of factor variable. Okay, so in one way ANOVA, only one factor. In a factorial ANOVA, you can put many factor, right? So now how the result will be different? You will not get the same result because it is making adjustment in the degrees of freedom, right? Okay, so because see, one thing you need to understand, the significant value is, okay, whether it is chi-square, okay, so we take the significant value based on degrees of freedom. So in the correlation also I was telling, so R, okay, we cannot fix this R will have this significant value, that depends upon sample size. Otherwise simple, right? Otherwise, based on degrees of freedom. Otherwise, it is the t value, right? What is t value is? T value is any estimate divided by standard error that we have seen. Any estimate divided by standard error, right? So now for example, yesterday I was telling, okay, I can find out okay, so let me go to that also. I will tell. Already some people waiting. So now, right. So if you look at this one, see, I have told you, no, right? See, always the t value, right? If it is a ANOVA, we are looking at the difference, the mean difference. Mean difference divided by standard error. Already we have shown in a regression. So in a regression, beta, standardized beta divided by standard error is the T estimate. In a correlation, okay, R divided by standard error. R divided by standard error, right? So now, okay, now look at what is standard error. Okay, standard error is simple, right? Okay, so square sigma divided by root n, that is the standard error. Sigma divided by root n, right? Okay, so now the sigma is variance. The sigma is variance. Otherwise, square root of sigma square, variance square, square root of sigma square. Otherwise, simply sigma. So you put square root of sigma square divided by square root of n. So now here the standard error is the 1 minus r square, right? 1 minus r square, that is the variance, how it goes. So divided by, since we are taking two variable instead of, because correlation we are trying to find out by two variable. So the degrees of freedom will be n minus 2. So n minus 4, so root of n minus 2, right? So now the t value is okay. So when this is divided by, so this will become r into, okay, so this will go up, right? Because r divided by this one. So r into square root of n minus 1 divided by 1 minus r square. So now our t value, okay, is depends upon r into n minus 2, right? So based on sample size, otherwise I should not say sample size, these degrees of freedom. So degrees of freedom, that is the degrees of freedom. So degrees of freedom depends upon the sample size, right? If it is one variable, degrees of freedom is n minus 1. If it is two variable, n minus 2, right? So now this t, right? Once you know the t, we know 1.96. That matter we know, right? If it is more than 1.96, significant value will be okay. So less than 0.05, like that. So the sample size, okay. So that t value depends upon the sample size, or otherwise we will say degrees of freedom, right? So when you put one variable, right, degrees of freedom is different. When you put the two variable, degrees of freedom will be different. So when you put two variables and three variables, if you look at the output, you can understand. So f value, all value will change. F value, all value will change. Okay, so now, okay, that is the simple thing I'm telling. Okay, so you can see the output, all right? You have to perform one way on our, right? What is the degrees of freedom, right? What is the value, right? All you have to see. Okay, so all you have to see. So I can tell how f value is calculated all, but let me not confuse with everything, right? So now, okay, please, okay, so now let me go again. So let me close all. Okay, income level. Okay, so this so let me close. So income level, right? So now please note down what is the result, how the result is changing. That also I will tell, right? So first of all, okay. So compare means, let me perform ANOVA. I will note down the result. Then I will tell how the result is changing. So saving I have put, designation I have put. Okay, first variable designation. So let me go to the output. Okay, so I could see 0.00, which means designation making a difference in the saving, right? Then let me go to another variable, compare means, one way an hour. Okay, so I'm changing here. I'm changing here. Okay. So age I am putting. Okay. So the age also 0.001, 0.001. So which means the saving is depends upon the age also. The age is making a difference. Different age category people they save differently. All okay. It's different sentences I'm using. So different age category people they save differently. There is a difference in the age category. All right. So different age people they are different. They are different. Then let me look at the compare means. Okay, compare means one way or another. So let me take again. Let me take out. Okay, so see, you need not take out. Okay, so this okay, take out. Put income here. Okay, so now there is a difference. Okay, okay. So now this is the one. Now, now, okay. So now analyze. Now, instead of performing 3 times ANOVA, right, I'm going to perform one factorial ANOVA. Where is factorial ANOVA? Right, this I will come to other things later. General linear model, general linear model, general GLM, general linear model, okay, univariate, univariate. So now only one dependent variable, that is why it is called univariate. So let me put total savings here and all other three here, all other three here, right? All other three here. Okay, other three here. Okay, so now all three here, right? Put together. So now if you look at it, okay, now if you look at it, okay, so now see here, the designation, look at the significant value 0.149, age 0.413, income 0.001, which means, right, which means so the different designation category, okay, actually there is no this one, right? Now look at the, see the F value, okay, so the degrees of freedom, it is not, okay, 551. Now if it is yearly one, 551, now you can see how it is changed. So it has become 440, 98, it has reduced very, because many things adjusted here. So 498. So that is why all values will be changed. So now, there is the result is entirely different. Result is entirely different. So there is no the real difference between different designation category with respect to saving. So which means just because designation they are not saving, just because age they are not saving differently, but only the income is making a difference. Just only the income is making a difference. So now when one variable alone, it might make a difference, right? But when group of people are there, only the variable which is making a real difference, that will be exhibited here. So variable which are having making small difference alone, okay, it will not have effect. So okay, what I want to tell finally is, see, it is a wrong procedure to perform different ANOVA when your metric variable is same. When by changing different factor variable, you cannot perform the many ANOVA. Okay, so that individually we can say whether when you take each variable separately, whether it is taking a difference or not, we can find out. But in a practical world, designation is also in existence, age also in existence, all variable are in existence, So we have to put all variable together only to find out which variable is really making a difference in the saving. Okay, so it is not advisable. in fact, I can tell it is wrong to put many ANOVA, right? When our dependent variable is same and our factor variable. See, for example, we will be having many demographic variables. So I have seen no one has performed factorial ANOVA. No one. Okay, again, there's so many reports are there. No one has performed factorial ANOVA. They will perform only the simple ANOVA many times. Many times. It is not advisable. It is not advisable. Your results are not applicable. Results are not okay practicable, right? So only this factorial ANOVA will be useful. So now we will perform. Okay, we will perform. Okay, so some more also, some more also. Okay, so now we have seen the individual effect that we call it as main effect. That we call it as main effect. Okay, so now, okay, so we have seen main effect, each variable what happens. So now we have some more also for which we will take up some more exercise. We will take up some more exercise. Okay, truck usage. Okay, truck usage. Okay, so I'll perform. I've taken. Okay, I've taken gender. Right. I've taken gender. I've taken dose. Right. I've taken dose. So both are 2 by 2 category. Okay. So otherwise, okay. So you can see many.
That's three. Three,
Yeah,
sir.
yeah. I will take another thing, madam. So each one it is different actually. Okay, so
Okay, sir.
different inference. So each example is different. Okay, it will make
Okay, sir.
a significant difference. Okay, so but anyhow, okay, so let us not waste much time. Okay, so now is it visible, madam?
Yes, sir.
Okay, so now I have noise, right? Noise produced by different cars, right? So now one variable is size of the car size, small size, medium size, large size car, right? So size of the car. So which car is making a noise and the filter. Okay, so normal filter, octal filter, two filters. Okay, so two filters and okay, so noise, the metric variable. So now let me perform straight away. Let me perform right. So let me put a fixed factor. Let me put fixed factor. So first we will see what happens. Then we will see one by one, right? So the car size is making a difference. Type of this one is also making a difference. And this I'm going to explain. Car size and this is called joint effect or both variable together, whether it is making a difference, right? What is together, we will see. So all are making a difference. All are making a difference, right? Very good. Okay. So okay. So difference. So now we look at the analyze general linear model univariate, right? We will look at the plots, right? We will look at the plots. Okay. So we'll put car size at horizontal. Okay. Then type we'll put in a separate line. Car size. Okay. Different car size. And we'll put type here. Add. Okay. So what is this plots? Okay. 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 So now, see now. Okay. So this is the. Okay. So see, look at the normal filter. Okay, look at the normal filter. So the small car here, medium sized car, if it is a normal filter, right, it is making a large noise, right? Okay, large size cars, okay, so large sized cars. So this one, right, okay, let us put in a different way, whether I will tell differently. That also I can tell. Let us see. So the plots, car size, let me put separate. Car size, separate line. Type, add. Whether I can get two times. So now, okay, you can see here, right? You can see here. Okay, so now, so this is a okay, small size car. Small size car, okay, so irrespective of filter, whether it is normal filter, actor filter, okay, so it is a small size. What color? Okay, so we color is not visible. We will make it as a okay. So this color we will change it to the large size actually. Okay, each one is not coming. So that itself we will see. So here I can change the color. Okay, so now. So now what happens? Okay, so now the large size cars, whether it is both filter, it is making a less noise, no issue. Okay, but in a small size car, okay, so which is a blue, okay, so whether both filter equally same, no issue, right? Both filter equally same. But medium sized car, okay, so if it is a normal filter making a more noise, making a more noise, but okay, so it octal filter, okay, so less noise. So it is touching, okay, in fact, after some time, if you go, it will cross. So when it crosses the line, we call it as a interaction effect. So when you plot this one, when it crosses, we will say there is an interaction effect. So some other place we will see, some other place we will see whether there is an interaction effect or not. Okay. So now if there is an interaction effect. This is the plot we are seeing, right? Then we'll see. Okay. Then we will see general linear model. General linear model. So now the options. We'll go to the option. We'll look at the descriptive. We will look at the okay. So we'll look at the display means so that we will understand more and more. The homogeneity test also you have to do, right? We'll compare. Okay, so descriptive we'll see later, right? The compare we'll do later. Okay, compare also we'll do. So this we'll do other things later, right? So now what we can see is we can see the marginal mean. Okay, so now this we have seen already all three different. So now look at the mean values. Small car, okay, so 822, right? 24. Medium sized car, it is producing more, right? More noise. And large size cars, it is producing. So there is a difference. So now let us compare, right? Which is having difference. So because we have put comparison, no compare. So that is why it is coming. When you have put only marginal mean, you will get this one. Now since we have put compare means it is comparing small size with medium size, there is a difference. Small size with a large car, there is a difference. So whether there is a difference in each that we can see, right? When you put the pairwise comparison, then we have noticed there is a difference in the type. Okay, so we look at normal filter. Okay, so more 815. Here octal filter 804, right? Whether these two, whether there is a difference? Yes. So normal filter, octal filter, there is a difference, right? Comparing these two, there is a mean. Okay, so there is a difference of 10, right? 815. What is the difference? 85. Okay, so that also we have seen 815, 804. There is a difference of 10. That itself a significant difference. That itself a significant difference, right? So now filter we have seen, right? Then we will go for the joint effect. We will go for a joint effect. See, what is this joint effect? Each car, right? This is the interaction effect or joint effect. Now, what happened in the small car? Both this one, right? In a small car, okay, 824, 822, there is no difference. See here, there is no much difference. 825 and this one, right? In large car also, there is no much difference, right? But in a medium car, okay, when you take overall what happens, so we are taking individual, right? So individually, okay, individually small say this one and this filter, right? So we are performing, right? So now, okay, so now in a small size car, okay, whether there is a difference, so okay, so there is no much difference here, right? In a medium size car, there is a huge difference. We have seen in the plot also. We have seen in the plot also. Large size car, there is no much difference. So within each category of car, in different filter, whether there is a difference. So this we are doing since there is a difference here. So we say there is a joint effect also. There is a joint effect also. So this is called the interaction effect. This is called the interaction effect or joint effect. Joint effect. So this also you have to see. Why? See, for example, this also I will explain, right? See, for example, we have taken, so no one has asked, okay, somebody should have asked, okay, so we have taken the employee data, right? We have taken the employee data that are deleted, right? Okay. So now let me take the employee data, whether it is there or not. Independent sample t test, I have. Here I have. This is Excel. Now open, let me see. I do not have in the Excel also I can open. So so I need to have the center, that is why. Here here right. See now. Okay, so now listen. Okay, so let me perform. Okay, one by one, right? See, analyze, compare means
So screen, sir.
screen. Very. Analyze, compare means, right? So what I am doing is one way on our. Okay, so now, sorry, I have many employees. Close some files. So now analyze, compare means one way on straight away. Let me put one way on. See, independent sample t test. Compare means independent sample t test. See, sex here. Okay. So one and two, one and two. Right here salary. Okay, so now look at the output. See, we have seen, right? So there is a difference. You have to see because this is less than 0.05. We have to see this one 0.00, which means there is a difference between male and female with respect to salary. So male is having 41,000 and female is having 26,000. There is a difference of 15,000. We have seen. But no one has asked me, sir, how come the male they have more salary, sir? How come female is having less salary, sir? Right. Okay. So if no one has asked, there is a difference of 15,000 rupees. So no one has asked. No one has asked. Say how come this company is useless companies are how it is giving a difference in the salaries are useless, right? Okay, so that no one has asked me. Now, see, let me perform one more ANAVA. Compare means one way ANAVA job category. Let me put a job category and the salary. Okay, so salary. So there is a in job category also. In job category also there is a difference. Okay. So now the point is okay, there is a difference. Now we need to analyze. We can see. Okay. So we will look at how to make further analysis, right? We should not stop here, right? So when the gender is making a difference, we should not stop. How come female can get less salary? You should think, right? We should, okay. So I'm trying. So let me go for, So let me go for analyze general linear model, right? So univariate. So let me put a salary here. Let me put a salary here. Let me put a sex and the job category here, right? Here, right. In the options, let me put the, okay, so let me put this job category and this one, right? Bonferroni. Okay, so Bonferroni is like turkey test. So madam is raised the hand. Sumitra madam, please.
Sir, I have a doubt here, sir.
Wait, madam. Wait, madam. Wait, madam. Wait. I will come, madam. I will take up the doubt. No problem. Okay. So now, see now. Okay. So now you can see. Okay. So what you can see is. See, job category, there is a difference. Okay. So sex, there is a difference. Job category and sex joined together, it is making a difference. Now let us see. Right. See, let us look at the this is a marginal mean. Marginal mean is little different from ordinary mean, leave alone that. So now look at okay, so employment category. Look at the mean value. Clerical, okay, this also we have seen there is a difference. Clerical 28,000, custodial 30,000, manager 56,000, right? So there is a difference. There is a difference 28, 30, 56. That is why employment category there is a difference, right? Now we are comparing with each. Now look at the clerical and custodial 28, 30. There is no difference. Okay, even see, I have told you know in ANOVA, even when there is a difference between two, okay, it will say there is a difference. Clerical and custodial, there is no difference, 0.472. Clerical manager, there is a difference. Okay, so there is a difference. Now let us look at the, oh, sorry. Male, female. Okay, so now, so it is a marginal mean. So, Sir Sumitra, madam, please down your hand, madam. Please don't raise hand. I will come. Okay. So now, okay, male and female. Okay. So now, six. Okay, male 42,000, 36,000. Okay, so there is a difference. Male and female comparison, there is a difference, right? So now let us go to the joint effect. Let us go to the joint effect. Right. Clerical, right? Clerical. Okay. So now clerical, okay, male 31, 25. So now in the manager, the average salary is 66 and female less. So the when you look at this one, so further we can understand. So there will be more number of male when you put the frequency where, so we have seen the already high square test. So where we have seen more number of male, right? Frequency, right? More number of male. So they have a they are the manager. So since a more number of male are managers, their average salary is more. Average salary is more. But here, okay, so the male, so provided when you look at, say here also, in the manager, okay, in the male they are having more, in the female manager they are getting less, like that. Then here also we are not able to find out much result. See, what you can do is we can look at one more category, experience, right? So probably the male managers, they might be having more experience. So male experience, one more variable we can bring in. So we to find out which is making what is the reason why the male salary or male people they are getting more. So probably because of their experience, more number of male or managers. So like that, their average salary is more. So like that, see, when you say there is it is making a difference, you have to look at, go deep and deep to find out which is the real cost, which is making. So that and all possible when you do only this joint effect, when you perform only this factorial ANOVA. When you perform ANOVA, we cannot find out the real, the which is making a difference, we cannot find out. We cannot make the this one, right? So that is why this factor joint effect we can find out, factorial ANOVA, all higher end tools, which will make a significant difference. So in the interpretation, right? So now doubt, Sumitra madam, what is your doubt, madam? Yeah, Sumitra madam. Hello. Hello, madam.
Sir,
Ah,
sir, can you hear me now?
yes, madam. Yes, yes, madam. Yes, yes, madam.
Sir, it's ANOVA, sir, factorial ANOVA. Here we have taken one variable as gender now, sir.
Hmm.
There are only two categories are there.
Hmm.
So before when we were discussing, we were discussing that we can't perform post hoc test if two categories are only there. So that problem will not come in this case, sir.
See, it will not come, madam. Post-hoc will not come. See, for example, let me go here. See, general linear model. Okay, so univariate. So here, when you put this post-hoc, when you put this post-hoc, see, it will not, when you put the sex here, it will say, I cannot perform post-hoc. Right. So it will say, right, if you put that post-hoc. But we are not performing that. We are going to these options. We are going to this option. We are performing with the marginal mean. Here we can put. Here, when you put here, you will get to the mean value. Hello? Hello, madam? This is also
So
like,
that problem is not there, sir.
no, no.
To
You will
select
have,
variable which is
no, madam.
having more
No,
than two categories.
no, madam. See, one thing, please
That
understand.
assumption is
No,
not required, sir.
no, wait, madam, wait. Please listen carefully, madam. See, you can perform ANOVA with two variable also. But what is the problem is you cannot get the post-hoc test. You cannot perform the post-hoc test. So whether even when you perform here, see for example, right? So now, okay, here let me perform post-hoc, right? Let me click this sex and let me put it here, right? So let me put, okay, so, okay, post-hoc. Okay, so that marginal mean is there. So okay, so here also, since we have already clicked the post-hoc, see here also the post-hoc will not come, madam. Here also the post-hoc will not come, right? So here also in general linear model also, it will tell. So where it is. Okay, so let remove all other things and I will come back. Some people are there, so disturbing you completely. Okay. General linear model, right? Univariate. So now the post-hoc, I'm putting this sex. Okay. Then continue. Now here in the options, let me remove. Okay, so let me remove all. Okay. look at here. Okay, so okay, so that category. So I think I forgotten to click this post worker. Let me put the post. So now I'm clicking the post log. I put sex, right? I put sex here, which is a 2 category, right? Okay. See here, no post log. It will not come, right? The mean value will not. You cannot see the mean value. Okay, you cannot see, right? The when it is 2 category, you cannot get the post log. Okay, wherever it is, wherever it is. So to avoid that, what we are doing is general linear model. So that is why I'm not clicking using this post log. I'm going to the options where I'm using display marginal mean for this one, right? So when I put here, I will get the mean. I'll get, so this will display the marginal mean, right? So I now I can get to the mean. Now I can get to the mean. Now I can see the mean. See my mean for sex. I can see, right? So if I click this general linear model, right, univariate. So in the options, if I click this compare and form for any, then I can see each taking like Turkey, taking one comparing with all, taking one comparing with all, that will come. So I will come, sir. Please, please do not raise the hand, sir. Okay, so I will come. Okay, so now I can see the comparison, right? I can see the comparison, right? So see here, the compare for everything, the comparison will come. Okay, so okay, one with all, the comparison will take place, right? Okay, so this is the okay, so this is the factorial ANOVA. So any some sir is asking doubt, any doubt now? Any doubt?
Sir, while interpreting, we have to mention about the mean also, no, sir?
Yes, madam.
Mean.
Yes, definitely, definitely. When there is a difference, you have to write the mean.
Thank you, sir.
If anybody have any queries, please raise your hand so that I allow you to make unmute. Yes, Chandra Kumar sir.
Hello, sir.
Yes, sir. Yes, sir.
Yeah, I will ask a simple query, sir. Generally, when do we go for independent T test? Because nowadays everyone is talking of ANOVA. So,
Sir, after so much time when you ask this question, what can I say, sir? After taking this much time when you ask this question, what can I say?
I understood, sir, but yeah, because too many options, that's why I got this.
Not too many options, sir. See, one metric variable, one category variable. When your category variable is only having 2 category, then you have to go for an independent sample T test, sir.
Okay, sir.
It will compare only 2 categories, right? So
Okay.
that in the okay defined range, you can put only 2 category between 1 and you can compare. See, when you have categorical variable, when you have 4 category, but you want to compare 1 and 3, that you can put in a defined range. You can put 1 and 3, that you can put.
Okay,
1 and 3 compare, 1 and 4 you can compare, but only 2 category we can compare, right? So
Okay.
when you use ANOVA for 2 categories, you will not get the mean value, sir. You will not get the post-hoc test, sir.
Okay, sir. Okay. Got it, sir. Clear, sir. Thank you, sir. Thank you.
Mhm. Yes, any other doubt? Kumara,
Good evening, sir. Good evening, sir.
Good evening. Good evening, sir.
Sir, we have the mean.
Yes,
And
sir.
why we have the means are already here? Why we are comparing marginal means, sir?
See, when we compare the groups, see the marginal meaning is, I'm not explaining what is marginal mean, sir. So the marginal mean is taking mean. Okay, for each group we will compare, we will take the mean, then okay, we will find out the average. So because of the each sample, right? So that one, see, for example, one group will be having more, one group will be having less. At that time, okay, so comparing the simple mean will not be useful. So compare the marginal mean. So in the marginal mean, so the effect of different sample in each group, that is eliminated, sir. That is eliminated because it is the mean of three mean. I see, for example, you have take a 3, 1. So it is the mean of 3. Okay, so that is the marginal mean, sir. So that is why here they are using the marginal mean to compare the interaction effect, to compare the other effects. Hello?
Any other doubts?
Okay. So now, okay. So now we have, okay. So factorial ANOVA, normally I will not take time, but since I'm explaining other things, I have taken time, right? Okay. Now I will go to one more thing, right? See what happened. What happened? See, when I was doing my PhD, this income and saving data is my own PhD data. Okay, I was doing ANOVA. I do not know that time this many things. So I was doing ANOVA. See, the designation making difference, age making a difference, income is making a difference. So I was working in a census of college. I was working in a census of college. So we used to go, okay, so food is provided in a common place, free of cost. So normally we will not go alone, we one or two people will go together. So I had one friend and now he is working with the PhD institute. So we will, at the time we will discuss all general issues. In the department, normally we will not talk much. Okay, when we go to lunchtime, that is the time for discussion because we will walk for till mess we walk. So when I was going that time, suddenly something has struck to my mind. How come this is just because I am professor, can I save more? But I know that professors are getting more salary. That is why the income is also making effect. Then I want to know whether the professors, this age is really making a difference or not. Okay. So then what happened? Okay, then I was thinking then, so then I have identified, okay, so I want to control the effect of some variable, right? I want to find out, okay, whether the income and the whether this, see, for example, here, let me take that, okay, so we will take many example, we will take many example. Okay, so now here, okay, so now analyze, okay, general linear model, univariate, right? I put this variable, right? I have one more variable, income, right? Income, which is a metric variable, please understand. That I have put a covariate, right? Okay, what is covariate is this variable, this covariate, okay, covariate should have relation with the dependent variable, right? Dependent variable, right? So this, I know that income is related with saving. So the covariate is having relation. So because of this relation, it might make a difference. So I want to eliminate that effect. I want to eliminate that effect. Then I was running. Okay, so okay, though so these two. So when I put ANOVA, I could find there is a difference. Now I have put income, which is a metric variable here, as a covariate, right? So then I have noticed. Then I have noticed. See here. So now the designation is not making a difference. Age is not making a difference. Even designation age put together is not making a difference. Only the income is influencing because it is a covariate. We say it is related, it is making a influence. So when you put ANOVA, each one, there it could make difference. But when I control the effect of income on savings, then the designation and the age is not making a difference in the savings. So I put one income as a covariate. I put one variable as a covariate. So that is called this is called the UNCOVA. This is called the UNCOVA. When you put one variable as a covariate, right? That is called UNCOVA. So this is UNCOVA is similar to partial correlation. But what is the difference? See, here the difference is same thing, same interpretation, controlling the effect, same thing. But here one metric variable, dependent variable is a metric variable, the factor variable is a category variable, right? Covariate is a continuous variable. In a partial correlation, all variables should be metric, right? We are trying to find out money, for example, money supply and gold price. Both are metric variable. Control variable, right? Controlling the effect of GDP. That is also metric variable. That is also metric variable. All right. So now, but the all other things same, but we will say relation, all these things, because we have used metric variable on both the factor variable. So here, since we use factor variable, right, each category, they have a different savings. So we use, it is making a difference, right? After controlling the effect of the control variable, whether the factor variable is making a difference in the dependent variable or the another metric variable, so that we can find out the UNCOVA. Okay, so this is called the UNCOVA. So now let me perform one more UNCOVA. Okay. Okay. So now, first we'll put okay. So actually you should put one by one, then only you can understand better. But since there is no time, okay, so I'm using general linear model. What is this? A general linear model, univariate. Okay. So now let me put okay. So one variable, that is the statistics 4, right? Statistics 4 as a dependent variable.
Sir, the screen
And
is not visible, sir.
oh, screen not visible. Okay, sorry. Okay, I'm checking whether Nandini madam is alert. Okay. So now section gender education, three variable I'm putting, right? Okay. So So now see here, section is not having not making difference. In the statistics score, whether it is A section or B section, not making any difference. Whether male and female, okay, we cannot say some male will be scoring more, some male will be scoring less. So when you take average, okay, we cannot say male and female, they are different. But when they have different educational people, what they have studied earlier, right? So they are scoring different marks. Probably when they have studied earlier PhD, they might be scoring more. Whether they have studied statistics, they might be scoring more. So the whether it is A section, B section, not making difference, right? So we are comparing the mean only, right? So one people will be more, one people will be less. Average only we are taking and comparing, right? So okay, education is making a difference, right? Education is making a difference. So now educational level, right? So now whether just because okay, so now what they have studied, so now we will control the, see here what we are trying to find out is, see they have admitted, right? They are admitted in the classroom. They are admitted in the classroom, right? So now one teacher is taking A section and B section, right? So in A section also some male is there, female is there, B section also. Now, okay, whether we can say that section people are intelligent, these people are not intelligent, we cannot tell because it is not making a difference, right? Now, whether we can say male or different from female, that is also not there. Now, see, one teacher is taking, right? Now we say that the education people, right, they have scored more, right? See, which means he has influenced more, right? They have learned more after coming here, after coming here, right? After coming here. So whether they have learned more, whether, see, we want to find out some teacher is taking a class, A section, B section, whether whether some section, so he has taught more like that, or some he has made influence on boys and girls, no, whether it is, or whether he has put reach the PhD people or like that. So we want to find out whether they have learned more after coming here. So I want to control the effect of, see, before coming here, before joining here, we have conducted a test. So that test is a pre-test score. So I'm controlling the pre-test score. I'm controlling the pre-test score, right? Pre-test score I'm putting here covariate. Okay, so covariate. Okay, then I'm trying to find out whether there is a difference. See now, see, section is not making any difference. Gender is not making difference. So education is not making difference. So which means we cannot tell this teacher is not influence anybody, right? See, some people they have scored more marks because already they had a knowledge. So already since they have studied something, they got some different knowledge. Okay, so that is why now they have scored more marks. So it is not because after coming here. Okay, so now earlier itself, that is why pre-test score we are eliminating. Pre-test score we are eliminating so that we can find out after coming here what happened. What happened? Whether the section people are learned differently, whether different gender people they have done differently, whether the different education people they have done differently after coming here. So that is why the pre-test score we have put, pre-test score effect we have eliminated to find out after coming here what is the effect, what is the effect we want to find out. So there is no difference. Okay, so everywhere, okay, it is the same. So he is not influenced. So he has, in fact, we can say no bias, right? No bias, which means He could not reach anybody. He could not reach anybody because okay, so no one has improved the marks because pre-test score marks is having real influence, right? Only the pre-test, not this gender. Okay, so he has not influenced. In fact, we can tell he is not biased, right? Okay, like that. Okay, so this is the UNCOVA. This is the UNCOVA, right? So now any doubt UNCOVA? Here also you have to learn one by one. Right? Here also you have to put the display means. You can ask, you can put display means. Okay, one by one you have to learn. One by one you have to put and you should try to learn one by one. You should try to learn one by one. So this is called the UNCOVA. Is it okay?
Any doubt? Chandra Kumar sir.
Sir, combined effect is also shown. Can you
Yes.
just brief on that, sir?
No, sir. See here. That you should, I can explain only with the marginal mean, sir, right?
Yes, sir.
General linear model, univariate. Okay. So that you can better understand by looking at the mean, right? So let us look at the mean. Okay, so only this I will put, right? Check. Okay, so I put, so since both are 2 by 2, just creating it. So now say okay. So now in the section A, male 60 and female 62. Look at there is no difference, right? See what the both we are taking section, okay, within section male and female, whether they are different. For every section we are analyzing, that is a joint effect, right? See, suppose if in this section, so these people 60, these people 70, female 70, then there is a joint effect, right? So we have to go within section, so there is a difference in the mean of male and female, so then which means there is a joint effect. Now what happened within section male and female 60 62, there is no much difference. Then here also within B section male and female, there is no difference, right? So suppose if there is a difference here, right, between 60 and 70, then we can tell there is a different joint. Joint means section, gender. Within section, every gender, whether there is a difference we are doing. So that is the joint effect. Right.
Okay,
I have told you, no. So
Yes.
within manager category, whether male and female, whether they are getting more different salary, right? So we will not look at gender alone, right? So every category, right? Every job designation category, male and female, like that we will look at, right? So when you look at the three variable, right? When you put three variable, right? See, for example, let us put, we have seen the three variable also we have. We'll put the three variable, then we will see. Okay, we put three variables together. Right. So then you see here, every section, then male, right? Every male for every education level. So whether there is a difference. So there is no difference. So okay, so here in the B section, right, 61, 62, right. In the female also 62, 63, right. So three variable we are within section. In that within male, three education level, right? Okay, like that we will do, like that. This is called a joint effect, right? When there is any difference anywhere, then it will say there is a joint effect. Now here there is a little difference. That is why the significant value is somewhat okay. So you can see significant value is okay. So it can okay. So it's not displaying. So here, okay, so we could not perform. Okay, so it says like that. So, okay, so like that it will perform, sir. That is the joint effect, sir. That is the joint effect. Okay.
Okay, sir. Thank you so very much, sir.
Thank you, sir. Thank you, sir. Then what else? Anything else? We'll go to the another one now. We'll go to the another one. Okay. So now let us take the same case. Let us take the same case, right? We will go one by one. So analyze now general linear model, right? Now this univariate is over, right? In univariate, we got factorial ANOVA and UNCOVA, right? Now, see, now I'm going for multivariate. I'm going for multivariate. So three site, so that is why it's multivariate, right? So multivariate, which means here also I can put a many variables, right? So now let me put IQ all, right? IQ, statistics, mathematics, three metric variable, right? Three metric variable I'm putting. Here, let me put three variables, right? So gender, right? Education level, I'm putting three variables, right? Okay. Right. So now let us say okay. So now let us see, it is giving, okay. So now let us take first, we will not take up this one. We will take up like ANOVA, like, right. See here, right. One by one, right. It is like ANOVA. It is like ANOVA, right. Right. So now we have put the three variable, right? Like ANOVA we have done, no? Many variable we can put on the top, right? Family oriented motive, self-support motive. Then each one, okay. So for gender, whether there is a difference, we have noticed. So now in bottom also we have put many. So with it is taking one section, right? One category variable. So it is trying to find out whether this section is making a difference. Section is making a difference in the IQ, no difference. In the statistics, no difference. Mathematics, no difference. So section is not making in. So in that section also, some people are getting good marks in maths, some people getting low marks. So we cannot tell. Now let us look at the gender. Gender also, IQ level, there is no difference. Statistics level, there is no difference. Maths, there is no difference. But education, we have already seen in a factorial ANOVA, we have seen in one statistics, we have seen there was a difference, right? In IQ also, there is a difference. Some people, those who have already studied higher level qualification, their IQ level is more, right? IQ level is more. So their education level, earlier education level is having a different, making a difference in the IQ, making a difference in statistics, making a difference in mathematics, right? So like they saying, okay, so this joint effect, like they say, there is a joint effect. Now, right? Okay, so now it is like simple ANOVA, right? And right, like factorial ANOVA with many variables, right? Oh, so each category, okay, all three. Another category, all three. Another category, all variable. So each variable, whether we are getting many significant value. So we are putting all together. So see the result, when you put individually, the result will be different. When you put this one, the result will be different, because the adjustments are taking place in the degrees of freedom. So that you need to understand, right? Right, very good. That is number one. Number two, right? Number two. Okay, so number two. Okay, so now this is a overall. This is a overall, right? The section is not making. This is a overall, including all three variables together. So probably when you put overall score, right? When you put add total marks, when you put total marks, right? So total. Okay, so again all variable together, all variable together, right? So the section, okay, so I'm going for a, so this is a overall, right? Multivariate test. So now the section, okay, the significant value is no, which means, okay, when you take a total marks of each individual, then when you perform the test, there is no difference. Section is not making a difference. But in gender, okay, so there is a difference, 0.003, 0.033. So which means there is a overall, there is a small difference. So there is a difference. Okay. Then in the educational level, okay, so definitely there is a definitely okay. So significant values are 0, 0. There is a difference. Okay, so now each one separately, this is a overall on all independent variable together, all dependent variable together. For each category variable, it is checking. So now here, okay, here you need to understand, right? See, there are many people. They have given their contribution. They have given their contribution. Okay, so they have given their contribution. Okay, so like Pillai trace, Bill's lambda, Cotling's T trace, Royce. Okay, there are 4 different tests to find out overall effect. So 4 different people they have contributed. So we have 4 different tests. Okay, so now, okay, so now which test we have to see? All right, see, normally we will look at the Pillai trace. Okay, so you can look at Wilks lambda is more, okay, more, okay, it is having more impact in the sense it is based on certain assumption. It is based on certain assumption. Pillai trace is not having any assumption, right? What is that assumption? What is that assumption, right? So now, right? In ANOVA, what is the assumption is this is ANOVA family, all are ANOVA family, all are ANOVA, all compare mean general linear model, all put together ANOVA. So we compare the mean to find out the difference, right? So now we have to check for homogeneity, right? So we have to check for homogeneity. Now, okay, so we have not checked the homogeneity. When univariate also you have to check. Everywhere you have to check. Everywhere, every time you have to check. Now, if you check the univariate, when you check the univariate, right? Let me go to the univariate and I will come back, right? Univariate we have already, right? So here also in the options, here we have homogeneity test, right? Here we have homogeneity test. So now the all 3 groups, right? Okay, so individual section, some groups are there. This one, right? So Okay, you can see the 11th test, right? So earlier we have not seen the 11th test. So see, if we click the homogeneity, right, ANOVA, independent sample t test, all homogeneity, whether the variance is equal or not, right? So the null hypothesis that there is no variance is not equal. So variance, there is a difference in the variance. That is the null hypothesis. There is a difference in the variance. So, but okay, so there is no difference. There is no difference in the variance. So, which means we should accept the null hypothesis. We do not want any variance. Any variance. The proof should be homogeneous, right? So now, what you mean by proof should be homogeneous? Distribution is same. So for this group also, see, the mean will be different. Mean will be different. For gender, the distribution is like this. For this also, distribution will be like this, right? Mean will be different, but the same distribution, variance is same. Okay, so we can say whether they are equally, say distribution is normal. Okay, like that. So now here we say, okay, significant value is greater than 0.05. So we accept the null hypothesis, which means they are homogeneous, right? So, okay, so there is no difference in the variance, no difference in the variance, which means they are homogeneous. We want groups to be homogeneous, then only you need to perform all. Okay, so this is the okay. So otherwise we should go for robust. We should go for robust other thing, right? Very good. So this is one. Now I'm going for a multivariate condition, right? I'm going for a multivariate condition. Now options. Let me click the continue. Okay. Now see here you will get 2 when you click the homogeneity. See, it will say for a factor variable, right? Categorical variable, right? Whether they are okay, the distribution is same. It, since we have many dependent variable, multivariate, many dependent variable, it will try to find out, since we have 2 dependent variable, all metric, right? I've already told you correlation, covariance. Whenever you have metric variable, we can find out covariance, x minus x bar into y minus y bar. That is the covariance. So it tries to find out the equality of covariance. Okay, so the covariance between the groups, covariance on the groups, on the dependent variables, whether they are same. Okay, so it says they are homogeneous, right? It also there is a homogeneity of covariance, so it should be greater than 0.05, right? Now when you perform multivariate condition, the box test, which is for covariance of the dependent variable, then we will have, okay, so Levin's test also. Okay, Levin's test also. This is also homogeneous. Now, since we have put 3 variables, right? 3 variables in each dependent variable, right? Whether the distribution is same, right? So 3. So all are homogeneous, So we can perform the path plot. Now, see, now I have told you, sir, when the assumption is not meeting, what to do, sir? That is why, right? You need not worry about the assumption. When you are not able to meet the assumption, then you use the Pilatus, right? Use, since here all are same because the sample is same. Okay, what is same sample? Male also 20, female also 20. Okay, so since the sample is same, I'm getting the same result for all. So Pillai trace. Okay, so when you are not meeting the assumption, you have to see the Pillai trace. right? When you are meeting the assumption, then we can use the predeterminant. So Pillai trace is a robust test, robust. So see, when you are not, see, we have conditions, we have assumption, when we are not meeting, see, but we need to check, right? When somebody asks, so whether you have checked, okay, I've checked, okay, it is not meeting the condition. Since it is not meeting the assumption, I have performed the appropriate test. I have performed the appropriate interpretation. So since it is a software, it will take care. It will take care all. It will take care all. So we need to check the play trace this one, right? See here, section A also 2020, mail also 2020, all equal. So that is why all giving the same result. Otherwise, it will not be same. Okay. So this overall, this is for okay, so this is for each okay section, whether it is making this, we have seen. Right. So now right, what is this test called? I have taken multiple dependent variables. Madam, Nandini madam,
Yes, sir.
what is this test called, madam?
Multi-vary.
Okay.
That is
So,
MANOVA.
this is called MANOVA, madam. This is called MANOVA. This is called what, madam?
MANOVA.
Right, very good. So now see, when you want to perform, see, MANOVA result is better than all the result, right?
Okay.
All the result, MANOVA result is more dependable than okay, performing independent, performing factorial, right? All. So when you use same variable again and again, okay, so use this MANOVA, and instead of performing many ANOVA, you have to perform MANOVA, right? So I've seen many theses, they will put 20 ANOVA, the 110, 50 pages they will write. Okay, 50 pages they will write. So even when there are no difference, they will put the mean value, all these things they will write. All these things they will do. Okay, so this is the one you need to know. Right, very good. So now I am going to perform one more general linear model. Okay, so this is MANOVA, right? Multivariate ANOVA. Now I'm going to put the pretest score in the covariate. Pretest score, right? So now I've seen the education, it was making a difference, right? Gender is not making a difference. Okay, so if you remember the, okay, so first we will see, right? We will see, then section is not making a difference, gender is not making a difference, education is not is making a difference. Overall, okay, gender is making some difference, education is making a difference. That we have seen, right? That we have seen. Now we'll go for general linear model, multivariate, right? So let me put a pretest score overall, right? After coming here, whether there is a difference. Okay, so that is why before we are controlling. Okay, all you can do, right? Options, plots. See now, education also is not making. So only the earlier knowledge is okay. So now, see, I'm taking financial management, right? So the commerce students, they will say all good answers. So, so at least I will say I could reach the commerce student. No, yeah. Okay, you are not reaching. Okay, already they have the knowledge. That is why they have scored more marks now, right? Okay, so that is the okay. So now see, interesting. Section and gender in IQ, there is a difference. There is a difference. So now if you look at the marginal mean, you can find out. Now let us look at the overall what happens. Okay, we can look at the Wilks lambda, right? Because we are meeting the sum. Now see here, education is not making a difference in overall also. Okay, so but the gender still it is making difference, right? See, now let us see carefully. This is multivariate test, right? Okay. So section, we will go one by one, right? Section is not making a difference. Gender, okay, overall, okay, when you add all the mass after controlling the effect, there is a difference. But education level is not in overall also, there is no difference. There is no difference. But section and gender, since gender is some difference, so we can see some difference, right? So provided when you put the marginal mean, you can see, right? Okay, you have to put and you have to learn slowly one by one. Okay, so this is called what? This is called what, madam?
Manova, sir.
Manova.
Oh, sorry, sir. Multivariate.
Now, what I have done, madam?
Mm,
Just like that telling, madam. Okay, so the Manova is, Manova means, okay.
multivariate.
Here we will not have any covariate. So we will have many dependent, many factor. So now this is Manova.
Okay.
So we have put one covariate. Right. See now, what is this?
Sir, voice is breaking, sir. Sorry.
What is this, madam? Hello?
Sir, covariant.
So this is called the Mankova.
Mankova.
So now let me tell again, right? See, one by one I will tell. Okay, one factor variable, which is having two category. Okay, that is called independent sample test. One factor variable, which is having three category, that is called ANOVA. When you put many factor variable, that is called factorial ANOVA. When you put many factor variable, only when you put only one factor, here many, that is ANOVA. When you put many factor, many dependent, that is called MANOVA. Right. When you put many factor, one dependent, one covariate, uncover. Many factor, one dependent, one covariate, uncover. Many factor, many dependent, one covariate, that is called the uncover. Now, you can put many covariate also. I have that example also. That is also Mankova only, controlling the effect of two variables. But okay, so then, okay, then instead of having two covariates, so the condition, right? So that I have not demonstrated. There are many conditions are there. that only the box test and homogeneity, that is Leven's test I have done. Now, when you have many covariate, what normally people will do is they will make us both variable as a one factor. They will make it as a factor score. They will save that factor score and they will put that as a covariate. So they will put two variable as a one factor, convert into factor score, and they will put as a covariate. Okay, that they will put. So now the condition is when you can put covariate, the covariate, okay, so I will check that also. For example, the covariate should be related with the dependent variable. Covariate should be related. Okay, that is one. So now, see, we will try to find out interaction between these variables, section and gender, section and education, gender, all three, right? We will try to find out interaction effect of all the factor variable, right? Right. So we will try section and gender, section and education, right? Is gender and education, section, gender, education, like that, right? So first these two, then these two, then these two, then all three, like that we will put. So that interaction we will try to find out, right? This, the factor variable, right? Factor variable should not have interaction effect this with covariate. So that is the collinearity. So this factor variable should not have any interaction effect, right? See, normally it will not give interaction effect. Then how to perform interaction effect, right? It will not report. It will not report, right? So it will report only the interaction effect for this one, right? It will not report the interaction effect of this factor variable with this one, right? So it will not report, but we need to check. We need to check whether they are having. So for which it will not give, right? We have to go for a custom. We have to go for a custom model, right? So generally it will not give. So we have to customize our model. So now see we need to, our model is each main effect. So for each variable, we will find out the main effect. We will find out the main effect. Okay, so this is our different factor variable. So we will try to find out main effect. Now we will try to find out the interaction effect of, okay, for example, each one, these two interaction effect, right? So education, right? Let us assume. So this one and this one. So here I want to find out interaction, right? So now if you put it here, it will give the one factor variable with covariate, right? Then it will report the interaction effect. Now you can see. Whenever in ANCOVA also you have to check, okay, because we are putting covariate, right? See here, okay. See here, there is a difference. This should not be there. So education level and pre-test, there is a relation. Okay, so it should not be there, right? So, okay, so it should not be there. Okay, so we should need to check that. We need to check. Then accordingly, we should not use the education level like that. Okay. Okay, so whichever we need to check one by one, and or otherwise you can put all section and pre-test interaction. I can put many interaction together, right? So how multivariate the model, right? I put only this one. I want to put interaction effect of this one and okay, this one. I'm using clicking control. Okay, I can use like this, educate, gender, and this. So I can use all, right? So this is I'm customizing the model. I'm customizing the model, right? So these are all the things you need to learn, right? So still the ANOVA family is not at over, right? Tomorrow also I'll take up the ANOVA family. Okay. So yesterday, one gentleman, he was talking about one sir, one I think PhD scholar, he was talking about whether I can perform on COVA, all these things. Okay. So I think he was talking about pre-test, post-test. Okay. So that he has to wait till tomorrow. So tomorrow also we are going to take up one more, right? So that he will understand better. Yes, sir. Any-
Jyoti Chaudhary, ma'am.
yes.
Jyoti Chaudhary, ma'am. Any two participants can ask your doubt by raising your hand.
No doubt. Normally, Kumarasamy Mora sir will ask question. Right? Sumitra madam will ask question. Today, Sumitra madam is not asking question. Madam, Sumitra madam, thank you is not important to me. Chandra Kumar sir has asked. Normally, he will ask question. Chandra Kumar sir, you ask question, sir.
Hello, yes, sir. So first of all, thanks for the session, sir. Sir, I don't have much questions, but have you got any YouTube channel or videos so that I can refer back whenever there is a query? Also, maybe in the future, whenever you are conducting a session, I would like to attend, sir. So that is what I wanted to check. Thank you, sir.
Very good, sir. Very good, sir. I do not have YouTube channel, sir. Okay, so many people they have separate channel. Okay, so but okay, so the sir will provide a recording, provide a YouTube facility for some time, sir. Okay, so
Okay, sir.
after completing this workshop, he will provide. So he will provide for some days, 10 days, 15 days. So
Oh.
with that time, you please watch carefully. Watch carefully. So I will
Yes.
provide the data set also, right? So then you have to learn, sir. Every day when you go home, you should not come back without performing, sir. Right?
Okay,
I
sir.
will send, sir. So
Yeah.
every day you have to go through and come, sir. Go through and come
Yes.
because next day I am going for new things. When you learn new things, old things will go away, sir. Old things will go away.
Yes.
But I am repeating every day. But even then, it will go away, sir. It will go away, sir.
Yeah.
Okay, so whatever I've learned on many years, I'm telling, sir, because I've learned I didn't watch YouTube channel. I've never attended any workshop. In fact, I've never read some of my students. They read the books. I will perform, sir, again and again. I will perform and I will see how the result is coming, sir. Oh, then, this is coming because of this one, right? This is coming because of that. I've learned only that way, sir. I've learned only that.
It's great, sir. That is why you are able to relate to real world examples. So we can, and also any notes or books of yours we would like to refer in the future, sir. Thank you.
PPT I will provide, sir. PPT I will provide.
Thank you, sir. Thank you very much, sir.
Definitely I will provide PPT, sir. No issue, sir.
Thank you very much, sir.
Chandran, sir.
Sir, am I audible, sir?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir. Sir, commonly, ANOVA and ANCOVA family to find out the main difference. What is the objective of the MANOVA and MANCOVA, sir?
All same, sir. All ANOVA family, sir. All ANOVA family. Still
Okay,
ANOVA
okay.
family not completed, sir.
Okay. I got it, sir. Thanks.
Okay, so now,
Sir,
sir,
another doubt, sir. Sorry. To find out the socio-economic status of the fishermen families in particular district, what are the statistical tools are more suitable, sir?
No, sir. See, please understand. You have to look at the variable, sir. Right? You have to look at the variable. You have to look at the data. Right? So when your data is okay, this variable is metric variable. This is a category variable. I want to find out difference. Right? So there is for anything and everything, this is the logic, sir. Right? So you need this can be applied to any situation, sir. Any situation. Look at the data, sir. That is why every time I'm telling, so this is the variable. So since I have one metric variable, I can, but when you write the inference, interpretation is making a difference, sir. Inference you have to write from your subject, right? See, for example, when you say gender is income is making a difference, you can tell the different income category people, they save different, so which means income is influencing, saving is depending upon income. Then Keynes has also stated the same thing. This finding is supporting the findings of the Keynes. Like that, you have tried.
Okay,
Okay.
sir. Okay.
So
Thank you.
now, see, many people they are asking these questions, sir. So now look at the data, sir. Look at the data, right? So if it is a metric variable, you can perform this one. Category variable, you perform this one, right? So that is the one, sir. It is applicable to whether it is a science. See, for example, many times the science people, when I was in earlier college, they used to bring journals. They used to bring journals. They will show, sir, this is the output that they have shown, sir. I want to get the same output, sir, right? My data, right? So then I will ask them to say, oh, sir, your data is having metric variables, sir, but they have used categories, sir. So it has to be converted, sir. Can I make it like this, sir? I will ask the question, right? So whether I can classify like this, okay, you can classify, sir. Then I will classify accordingly. I will perform and I will put them, sir.
Okay, sir. Thank you very much. Very outstanding session, sir. I am realized very fantastic. I attended in second workshop, sir. You are, thank you so much, sir. I am research scholar. More benefit to your delivering your lecture method and delivering style. All are outstanding, sir. Thank you, sir. Thank you so much.
Thank you. Thank you, sir. Thank you so much, sir. Thank you, sir. Thank you so
Thank
much.
you, sir.
Thank you, sir. Thank you, sir.
Sir, one more person, sir.
Yes, madam. Yes.
Sarkar, sir.
Good evening, sir.
Good evening, sir.
Actually, yesterday I have asked about the pre-test and post-test, and it will be great pleasure. Tomorrow we'll learn. So today I haven't any question. Just I want to see the data view. Sir, shall we?
Yes, sir. Yes, sir. Tell again, sir.
I want to see the data view option, sir. In your screen, we are seeing the variable view. Just I want to see the data view.
You want to see the data?
Yes, sir. Data view tab.
Ah. See here, this is the metric variable, right, sir? Hello, sir. Can you see or not, sir? Screen is visible to you or not? Visible only.
Yeah.
Visible or not, sir?
Yes, sir. Yes, sir. Is it visible, sir? Thank you so much, sir.
Okay, sir.
Thank you, sir.
So tomorrow also you wait, sir, right? Tomorrow, can you tell tomorrow what I am going to teach? Anybody? Okay, I will tell. Okay, see here, this is also, this see here, I taught independent sample T test, ANOVA, right? This general linear model, okay, I've taught univariate and multivariate. So this, I have to teach this one sample T test, which is not that important. Okay, that not important, but people are using very wrongly, so I will not teach it. Tomorrow, I'm going to teach this paired T test, and I'm going to teach repeated measures test. Repeated measures ANOVA. All are ANOVA families, sir. All are. This is called repeated measures ANOVA. All right. Multivariate ANOVA, univariate ANOVA. All right. All are ANOVA, sir. All ANOVA family. Both compare means, all compare means only. All comparing the means only. All difference only. All the words same. All. Okay, whatever we have seen today, whatever I have seen that day, tomorrow, whatever we are going to see, all compare means all ANOVA family. All ANOVA. So tomorrow the problem is, okay, why I am taking paired T test and repeated measures ANOVA, both are same family, right? Comparing mean only, but little away from regular ANOVA. Okay, that we will see tomorrow, sir. Thank you.
Okay.
Madam, shall we stop, madam?
Yes, sir. Yes, sir. And dear participants, please find feedback link which is there in the chat box. It will be active another 1 hour. Okay. Thank you so much, Kashalingam sir, for your
Madam, today I have not troubled you anything, right?
from yesterday. You are not troubling me, sir. Some participants are asking to you make me to trouble so that they can understand better. I don't know how much it is. Yes
See,
or no?
see, because I feel I have to cover many things. So,
Okay. Okay.
so that is why, okay. So still, I thought I can complete factor analysis
Okay, sir. Okay.
plus
So that
discriminant.
you can cover more.
Now that is.
Okay, sir. Fine. Thank you so much, sir. I also thank our research cell coordinator, Shiv Kumar sir, and our Professor Jairam, principal sir, and all the participants who are very active for entire session. And I also look forward your active participation for another 3 days. Thank you, one and all.
Thank you, madam. Thank you. Thank you.
Thank you, sir.